These set of videos, we're going to just see the problems that are related to the equilibrium of forces. So we have done some problems in the class, and of course, as I told you in the class, the problems are not that much complicated. So what we are going to deal here is a little bit complicated problem. So without wasting any time, we'll directly get into a problem. So this particular video will be just seeing about only one problem, and I'll be posting another video wherein a series of problems will be dealt with. Okay, so the problem goes like this. Fine. So over here, if you see, the problem that has been defined is almost similar to the previous problem that we have dealt in the class, but there is a little bit difference. The difference actually comes because you have two weights of equal magnitude, that is 1000 Newton each, are hanged in the same string. So when you're going to solve this particular problem, again, you're going to get into the concept of equilibrium of forces, as well as you're going to solve using the Lamy's theorem. But the difference, where the difference is going to come, is the main point that we have to look over here. And of course, you can see the problem and you can go through it. So the problem goes like this: a string ABCD attached to fixed point A and D has two equal weights attached at B and C. The weight rests with portions A, B, and C, D inclined at angles as in figure. Find the tension in the portion A, B, B, C, and C, D of the string if inclination of portion B, C with vertical is 120 degree. Right? So this is the problem that has been taken up for the discussion. Right? So we'll get into the problem directly. Fine. So this is where this particular problem is a little bit different from the one that we have seen in the previous class, and where the difference is going to come. It's very simple. Here we have 2 points B and C. Okay. So for B, at point B, what you're trying to do is you're going to try to go for a free body diagram. Okay, so this is your free body diagram for the point B, and this becomes your free body diagram for the point C. Okay, so here one thing that you have to look very carefully is the angle that has been created by the forces, the vertical or horizontal, and then you have to do it accordingly, right? So what we'll do is we'll break the problem such that the same problem A, B, C, D is present, but we are going to see it in a different fashion such that B point will be considered separately and C point will be considered separately, and then the calculation which we have done in the previous problem will be adopted. Okay, so this is the problem that has been given to us, and here what we are going to find is very simple. So first we'll try to solve the problem in the normal method wherein equilibrium forces will be considered. So if I say that equilibrium, I'm sorry, so if I say about that equilibrium forces are going to be considered, one second please. Yeah. So if I'm going to say that equilibrium forces are going to be considered, then it's very simple. You have two conditions. One is sigma fx is equal to 0, and the second is sigma fy is equal to going to be 0. So which means we have to see the number of forces that are acting on it, and here it's very simple. You have force number 1, that is the tension in the string BC, force 2, that is tension in the force AB, and then an external weight of 1000 Newton is being applied with. Okay, so this angle 30 degree and 120 is already given to us in the problem directly without any issues. Now, how is that this particular angle 30 degree is taken, right? I'll just go to the previous slide that will give us an idea. Right. So over here, I hope remembering that we have discussed, if you have a Z-shaped object, then the angle caused by these lines are nothing but one and the same, theta, right? So over here, you have a shape Z that is being formed. Okay, so this is the Z shape that will be formed. Okay, so obviously this angle is going to be 30 degree, and this is what we have taken into the next slide, right? So here in the problem it was mentioned that this particular angle is 30 degree, and then obviously this is going to be 30 degree, right? Now comes the question of going for its horizontal and then the vertical component. So we'll just take one at a time. So this is the force that we are going to consider as of now, right? So over here, you're going to have TBC cos some value. What is that particular value? Okay, here the total angle that is given is 120 degree, but out of which this is clearly known to us. Okay, so what is going to be this angle? It is very simple. The total angle is 120 and then 90 is the one that is known to us. So obviously it's going to be 30. Okay. So over here it is going to be TB cos 30, and then you have another force acting in this particular direction, and this force is going to be TBC sine, right? So force, then we'll go to the next force over here, right? Again, as I told you, when you're going to consider the angle, always consider it is with respect to the horizontal axis. So this particular angle is given as 30, and again over here it is 90 degrees. So obviously this is going to be 60 degrees. So over here you're going to have TAB sine 60, and in this particular area you are going to have a value as TAB, I'm sorry, this is cos 60, and over here it is TAB sine 60, right? So if I just write it in a much simpler form which can be understood, so here you have a weight of 1000 Newton. In addition to that, you have this particular force, so that is TBC sine 30, and then you have another force that is acting on top of it, right? So that is TAB sine 60, and then you have this particular force that is T cos 30, and then you have this particular force that also we are going to consider. So that is going to be TAB cos 60, right? So this is done. Now it's very simple. We'll get back to the normal case, that is sigma fx is going to be 0. So if you consider the x-axis, then you're going to have two forces. One is TBC cos 30 and TAB cos 60. So TBC cos 30 is lying on the positive side of the x-axis, so it's going to be plus TBC cos 30 degree, and then you have a minus sign because this is on the negative side of the x-axis, so that is going to be TAB cos 60, and then that is equal to 0. That these are the only two horizontal forces that are present. And then you have another condition, that is sigma Fy is equal to 0. So if you consider the y component, or say the vertical forces, force number 1, force number 2, that is the weight, and then you have a force number 3, right? Out of which TAB sine 60 is actually lying on the positive side, upward direction, positive side, whereas 1000, as well as TBC sine 30 is in the downward direction, so which means you're going to have a negative sign. So minus TBC sine 30 minus 1000 is equal to 0. Okay, so you have equation number 1 and your equation number 2, right? So now what you're going to find, you have two sets of equations, you have two unknowns, one is TBC and another is TAB, and then you can solve it, right? But please make a note that when you are going to solve this particular problem using the calculator, wherein you will be going for the equation and then you're going to type it, of course you can take it for guaranteed you're going to have an error as math error. Your calculator will not have the capacity to solve this manually. Okay, so if you want, you can go to your basic maths textbook and then you will be able to find out the reason. If you are going to use the calculator, then obviously this is going to be a problem. So there's no other go, you have to calculate that manually. So which means, I'm sorry, just one second. Right. So here it goes. If you're going to calculate it manually, you can take the first equation. So that is going to be TBC cos 30 is equal to TAB cos 60. So which means you can always write TBC is equal to TAB into cos 60 divided by cos 30, and I hope the answer is 0.577, and then again you should take this value and then substitute it back in this particular set of equation, which I'm not going to do, but I'll give you the answer directly. So if you're going to solve it, you're going to get the answer of TAB as 173.05 Newton. So this is the answer that we'll be getting when you're considering sigma fx is equal to sigma fy is equal to 0, which basically means we are trying to go for the equilibrium condition. So this is the answer that you're getting when you're considering that equilibrium forces are present, right? So we'll try to do the same problem, or let's say the same part of this particular problem using the Lamy's theorem, right? So if you go to the Lamy's theorem, then this is the first set of equation. Of course, we have seen all these things. Let me just get back to that, right? So according to Lamy's theorem, it's very simple. So let me just consider this portion for explanation, okay? Then we'll see the others later. So if I'm going to consider this, it's very simple. Three forces are there, okay? So 1000, again TBC and TAB are the forces. So if I'm going to consider this 1000, then divided by this angle or sine of the angle between the other two forces. So this is the angle between the other two forces, and it is very simple. It is 120 plus 30, which is actually 150, okay? So this is your sine angle of forces, okay, or let's say sine law of forces, okay? So it is 1000 divided by sine 150. So this part is done. Then we'll get to this particular part, okay? Now here TBC divided by sine of the angle between this particular, or let's say between the other two forces. So which means you should be considering this angle, right? So how is that you're going to find out this angle? Again, it's very simple. This is your axis, this angle is, and then you have another angle which is over here. This we have already found out, or you can say it is 60, because again here this total value is 90 degree, out of which 30 is given to us. So this is obviously 60. So this angle is very easy for us to calculate, which is 90 plus 60. Obviously again it is 150 degree, right? So this is also done to us. The final part is this one. So when you are going to this final part, how is that we are going to calculate? That is TAB and the sine of the angle between these two things, right? So between these two forces, I'm sorry. So this is the angle that you have to find, okay? Again, it's very simple. So if we consider this, it is actually a straight line. So the total angle from this line, or the total angle that will be formed, is 180 degree, out of which 120 is already known to you. So this angle is very simple. It is 180 minus 120, and then you're going to have it as 60, right? So now this is also is found to us. So after which you have to just go for the calculations, and then you have a value for your TAB, right? So if you try to recollect, or if you replay the video, you'll be able to find when we found it out manually, TAB had the value of 1732.05 Newton, and now we are getting as 1732 Newton. And obviously both these things, although these are two different procedures, the answer is just one and the same, right? So now what we have done is actually one part of the problem, wherein you have another part of the problem which we have to take care. So now what we have done is very simple. We have found out, or we have completed for this particular part. So now this is remaining. We'll get back to this now. Okay, so this is the problem that we are going to see as of now. Sorry. Again, I'm not going to have found out the angles and other stuff. You can try to do it on your own. So this is the angle that will be caused. So again, the same principle, you can solve it using two different ways. One is very simple, that is sigma fx is equal to sigma fy is equal to 0. Okay, so this is the one that we are going to see as of now. Okay, so what are the forces that are there? Again, you're going to have three forces over here, TCD, TBC, and then you're going to have 1000 Newton. So again, TCD is going to have a horizontal component and a vertical component. It will be very easy for us to calculate. Okay, so this is TCD. I'm sorry, it's D. And here comes the question. This angle is what you have to find. It is very easy. It is 90 minus 60, so it is 30. So it is TCD cos 30 in this particular direction, and then you have it over here, that is TCD sine 30. Similar is the case over here. You're going to have it as TBC cos 30 because it is just the mirror image, so the same value you're going to get over here. And you have another force that is TBC sine 30, right? So if I go for the condition sigma fx is equal to 0, it's very simple. It's TCD and then TBC cos 30. TCD that is present over here is positive because it's lying on the positive side of the x-axis. So it's very simple. TCD cos 30, and then this force is there negative side of the x-axis. It's going to be minus TBC cos 30, and then that is equal to 0. The next is sigma Fy is equal to 0. So you are going to have three forces, the weight 1000 Newton, TCD sin 30 and TBC sin 30, out of which TCD sin 30 and TBC sin 30 are lying on the positive side. So obviously it's going to be TCD sin 30 plus TBC sin 30, and then the weight negative side, so it is minus 1000, that is equal to 0. So you have your first set of equation and then you have your second set of equation, two unknowns, two set of equation. You can find out the answer. Here again you can directly use your calculator, you will be able to find out the answer. So the answer goes like this. It is TCD is equal to 1000 Newton, right? So we have found out the answer, and then if you want to find out TBC, then again you will be able to find that is also equal to 1000 Newton, right? So if you want, you can do the calculate, use the calculator and then do the calculations manually, right? Now this is when we considered that we have a equilibrium condition, right? So which means there is another way of solving it, that is obviously your Lamy's method. We'll just try to use that, okay, and then see how is that we are going to find it out. So this is the problem, and here is your Lamy's equation. Again, the angles, how is that you're going to find it out, is already known to you. We have discussed that, so it's very simple. So it is 1000 divided by the sine of the angle between the other two forces. So obviously plus 60, 120 degree. And then when you're going to go for TBC, okay, so this angle is the one that we have to find. It's very easy for us. This angle is 30 degree because as we know it is perpendicular, and then this is also perpendicular. So this is the angle that we need to find, and obviously it is going to be very easy, that is 90 plus 30, which is actually a 120 degree. So it is going to be TBC sine 120. So this is the first component, and then when you again go for the TCD that is being present, again the same set of options will be available for you, right? So this is also 120 degree. So if you do the calculations, of course sine 120 and 120 will be cancelling out, so you're going to get it as 1000 Newton. Again, if you replay the video, you'll be able to find when we found it out manually, you had a value of TCD as 1000 Newton, right? So obviously, which means regardless whether you're going for the equilibrium condition, please excuse me with the handwriting, it may not be good. Okay, so when you're going for the equilibrium condition, that is sigma fx and sigma fy will be equated to 0, or when you're going for Lamy's theorem, wherein again I'll repeat, three forces and they should be coplanar. Okay, So if you are going to solve the problem either by this method or by this method, you are going to get the same answer. You don't have to worry about which method you're going to adopt, but it's always better you know both these methods, and then try to solve initially a problem using both these methods, check for the answers, and then we'll go ahead. Okay, so I'll just finish off this particular video with this one set of problem. Maybe later I'll be posting another video wherein another problem will be dealt with. Okay, so thank you. I hope you have understood the problem to a greater deal. We'll see about the another problem in the next class. Okay, fine. Thank you.